Hello students, today we are going to discuss very important topic in covalent bonding, that is resonance. Before discussing the resonance, just I want to tell about Lewis structure. Lewis structure generally gives the idea about the valence electron of the atom in a molecule. How many valence electrons are available around the particular atom in the molecule, we can know from Lewis structure. But Lewis structure cannot explain the all properties of a compound. For a particular molecule, the properties cannot be explained by Lewis structure. But another structure, very different variety of structures can be drawn for a compound, for a molecule. That structure can explain the chemical and physical properties of the particular molecule or particular compound. That can be explained only by resonance. So resonance is one phenomenon, one properties by which two or more structure can be drawn, can be written by redistribution of electron from one atom to another. That means it is the phenomenon of writing two or more structures of a compound by redistributing the electrons from one atom to another. That means electron means it may be a lone pair, may be bonded pair of electrons. There are generally two pairs of electrons. There are two pairs of electrons available in the molecule. One is lone pair on the atom, another is bond pair between the two atoms, bonded atoms. So redistribution of that electron among the molecules, so how it will be, electron will be shifted, it will be redistributed from one atom to another in the molecule. That is called resonance. So the resonance, all structures that will be drawn are called resonating structures. These are called resonating structures or called canonical forms. It is also called canonical forms or resonating structures. Before discussing the points, one thing I will tell you. Suppose the structure of ozone, already you have drawn the Lewis structure of ozone. This is the Lewis structure of ozone molecule. Okay? As it is the Lewis structure of ozone molecule, we can say that this structure indicating what? One double bond, one oxygen. One single bond and one double bond in the ozone molecule. That means it has only double bond and single bond is showing. But actually, experimentally, it is observed that ozone molecule has the bond. Suppose the bond length of ozone, if you study the bond length of ozone, the bond length of ozone just lies O single bond length is 148 picometer. And O double bond is 148 picometer and O double bond O is 121 picometer. One is single one is 100. This is 148 picometer and this is 121 picometer. So two types of bond available, but it is observed experimental that oxygen bond length lies in between these two, that is bond length of oxygen in bond length of oxygen bond length in ozone is 128 picometer, not 148 or 100. Although it has single bond and double bond, but bond length lies in between 148 and 128. 21. In between this range it comes. Why this type of variation? Why this type of properties observed in case of ozone? We can know this thing by resonance. Because if you see the structure of ozone molecule, this bond can be written another way. Just we can see that as oxygen carry triple bond here, double bond one side, another single bond, it carry plus charge, then this is minus charge. This is one structure to satisfy the valence of oxygen. This structure also can be written as a different way. Here let it be O minus and this will be O double bond O. Okay. So, depends upon the availability of lone pair on the oxygen atoms, the structure will be like this. The structure will differ. So, this is a one structure of ozone and this is also one structure. Both structure is equivalent, we can say. Here double bond and single bond, here double bond and single bond. Both carry here minus charge, here plus charge. So, these two structure only can be explained by, we can say, if you see, it is explained by resonance. So, this, we can say this double bond and single bond character, the double bond and single bond character of ozone is, this bond length is 128 instead of 121 and 48 due to transfer of electron, that from single bond becomes double bond becomes single bond. If you see, now it is double bond character, now it is single bond character. Now it is double bond becomes single bond, now single bond double bond. So, change in bond length, change in nature of bond due to resonance. That's why the bond length of oxygen in ozone is lies in between 121 to 148. So what are the, before drawing different structure, what are the rules for the resonance? Let us discuss. First rule is structure should have same atomic skeleton. Atomic skeleton should be same. Atomic skeleton means the position of atoms will not be changed. Here oxygen position remaining same, is not changing. Then should have same number unpaired. That means if you count the total number of unpaired electrons in the atoms in the whole molecule is remaining same. If you count number of that, but the position of pi bond, this is a sigma bond and pi bond. So now it is a sigma bond and pi bond. So position will be changed, but the total number of unpaired electrons, non-bonded electrons remaining same in the molecules. More electronegative atom carry negative charge. That is an important rule. If there are two types of atoms, one is electropositive, another electronegative, or more electronegative, another is less electronegative. More electronegative atom always carry negative charge during the shifting of electrons. That is very important. So, the electronegative atom always carry negative charge. Like charge should not be placed together. That means 2 plus or 2 minus should not be placed together. Because like charge repel one another. That's why the stability of the molecule will be decreased. Then resonance hybrid is the most stable structure. Very important here. What is resonance hybrid? Resonance hybrid, if you say that as different, suppose this is a structure 1, this is a structure 2. Structure 1 and structure 2, but which is the most stable structure? That the structure between 1 and 2, there will be, we can say, if I draw, the structure is like this. What does it mean? That means here, as it has a sigma bond pi bond, here also sigma bond pi bond. That means this pi bond is circulating between these two atoms to another two atoms. That means shifting of pi bond from this to this. As shifting of pi bond takes place, this structure is called resonance hybrid structure. Resonance hybrid is just a hypothetical structure that is showing it indicates the nature of taking together. This structure, resonance hybrid, indicates the nature of first and second structure. So it is the resonance hybrid. It is the altogether of two structure. It is the representing the structure. This structure is the most stable structure. Most stable means lower energy. So during this most stable structure of among the all structure is called resonance hybrid. If you draw this energy relation between different structures, suppose this is structure 1, let it be structure 1, this is structure 2, let it be these two structures, second structure is the more stable structure, and resonance hybrid, this is the resonance hybrid structure, most stable structure, and this energy gap between resonance hybrid and more stable structure among the other structure of resonance is called resonance energy. What is resonance energy? It is the energy difference between resonance hybrid and more stable structure. That means lower energy structure and resonance hybrid. This energy difference is called resonance energy. That means during conversion of one structure to another structure, energy is released. That's why stability of molecule increases. How much energy released I can calculate. That means the more stable structure among the structures and resonance hybrid. This energy gap is called resonance energy. So, what is resonance hybrid is the most stable structure. This resonance hybrid is the hypothetical structure. It cannot be drawn only by taking all structure. It is represented in hypothetical way. So, this structure is the most stable structure. So, these are regarding the rules of resonance and the definition of resonance. Now let us discuss the different resonance structure. For example, carbon dioxide. This is the structure of carbon dioxide. Generally, this is the structure of carbon dioxide having two lone pair. If you see the Lewis structure, this is your resonance, this is your carbon dioxide structure, but you can start here. You take this lone pair to this indicates a shifting of lone pair. That is shifting of what? Electron from oxygen towards carbon, then automatically it will be shift toward this. What is the resonance now? If you draw, it will be O triple bond C. Now oxygen become plus charge because the electron is shifted towards carbon, so it is plus charge. Now double bond become triple bond. Now this bond breaks and single bond, oxygen carry minus charge. You see earlier O lone pair shifting to carbon, then double bond is shifted towards oxygen. Shifting of, already I have written, redistribution of electrons. Electron will be redistributed among the atoms. Here oxygen towards carbon, then carbon towards oxygen. Like this. So this is a structure 1 and this is structure 2. We can write another form is like this. Also we can write just reverse way, that O here if you shift toward this, it will become triple bond C, then single bond minus, then this will become plus. So like this. You can say this is structure 3. So this structure indicates 2 double bonds, and this structure indicates triple bond and 1 single bond, and this indicates is what? Position of triple bond changes. So this thing is possible only by resonance. So this is the structure of resonance structure of carbon dioxide. Here electron is shifting from oxygen to carbon, then carbon to oxygen. Redistribution of electrons, shifting of electrons. One thing we have to remember during resonance, the pi electron involved. Pi electron is involved. Pi electron involved means pi electron, new pi bond is formed or the old pi bond breaks. Here new pi bond is formed due to involvement of lone pair, and here the pi bond breaks, becomes single bond. So you have to practice like this. Similarly, if you draw the carbon dioxide structure, this is the structure of carbonate ion. This is the structure of carbonate ion. So what you will draw here? You see first structure, shifting of electron to this, then like this. So now it is minus, now it is O, then like this. Then you can draw also another structure here, like this. Now this is O minus, this is O minus, now double bond O. We have to see the position of electrons and its shifting. Here just you see this minus charge shifted toward this carbon, automatically this pi bond breaks. Shifting of electron, it cannot be remain in fixed, it cannot be remain in one position. It will be delocalized. You can say delocalization of pi electrons. Delocalization of pi, delocalization of pi electrons. Delocalization of pi electron. The pi electron is delocalized from one place to another. Here, this lone pair forming a pi bond, then gold pi bond breaks like this. So these are the structure. How many structure? One structure, second structure, third structure, like this. So similarly, if you draw the structure of sulfate ion, if you draw structure of sulfate ion, it will be like this. Minus, minus, this is the sulfate ion structure. If you draw the resonance, it will be like this. You have to see the shifting. Okay, then another way you can draw. Yes, double bond O, double bond O. Now it is single bond O minus, single minus. Similarly, you can draw another way. You can draw like this. This better you draw from this side. Already it is exist. This convert to this. Then it will be like this. So how many structure produced? 4 structure. Structure 1, structure 2, structure 3, structure 4. So different types of resonance structure can be drawn. By taking one structure, you can draw different type of structure. Only we have to follow from which side you start the resonance. Let us take another example. I can draw the resonance structure. Just take benzene molecule. We know this is the structure of benzene. 6 carbon in a cyclic structure. This structure can be written. You see, this is the position of pi bond. If you write this shifting towards this position, this shifting toward this position, this shifting toward this position, shifting of pi bond. That's why called delocalization of pi bond. Delocalization means pi bond is not fixed. So the new structure will be like this. Now it is pi bond. Now it becomes pi bond. Now it becomes pi bond. If you see, this is the structure 1. This is structure 2. And this structure 1, the pi bond position, and structure 2 pi bond position are different. That means here double bond becomes single bond. Now single bond becomes double bond. So change in position of pi bond, that is called resonance, because the same skeleton, carbon having benzene, this is called benzene. This example name is benzene. So benzene has 6 carbon, 1, 2, 3, 4, 5, 6. And benzene has also 6 hydrogen. This is hydrogen. All are hydrogen. All are hydrogen. 6 hydrogen and 6 carbon. Benzene formula is C6H6. CCH6. It is also CCH6, but only position of pi bond is changing. So this type of structure this structure can explain the properties of compound. Why benzene is a very stable compound. But the Lewis structure that earlier that we have read, Lewis structure cannot explain the properties of a compound. And it can explain the properties of compound. For example, why benzene is stable? Because the pi bond is not fixed in one position. The pi bond is circulating throughout the ring. That's why R is not fixed. R is a delocalized pi bond, so very difficult to react with other reactants. So that's why benzene is a very stable compound and it reacts under condition, under specific condition it reacts. Normally it is a very stable compound. Why it is stable? Because it has resonance. If number of resonance will be more, then the stability of compound also more, because if number of resonance will be more, then resonance energy will be more. If resonance energy is more, the difference of compound will be more, then stability of the compound will be also more. So this is regarding the formation of resonance structure to write 2 or more structure of a particular species by redistribution of electron. Okay, you practice more example from your books, different competitive books, and difficulty we can discuss in the next class. Okay, thank you.